Well, good morning, everybody. I guess it's not morning. Might be afternoon, might be midnight. Who knows? The love of video. All right, we're going to talk about arithmetic series. Arithmetic series. So when I started this, this is where people can go off and just play. These sequences are so amazing. I just watched a video on Penrose tiling last night, and the sequencing that goes in there is more geometric than numerical, but the algebra and geometry always are hand in hand. So you can speak this language or this language. Very cool. All right, man, what's our goal? Our goal is to get a formula today that can add up the terms of an arithmetic sequence. So remember, a sequence is a list. That's just a list. But when we take that list, we put plus signs in between them, we become an arithmetic series. All right. So what's our goal? Find a formula that will find the sum of any finite arithmetic series. Any one. Okay. So a formula means you're just going to plug stuff in and it should give you that. So, wow, how does it relate to all the differences? All right. So if you're paying attention on the sigma is like a pure notation thing, and it's a little awkward at first, but some of the problems that we did at the end were developing a formula for that specific arithmetic sequence. Great. I'll have that in my back pocket. But we need to step away and make it a little bit more general so it will work for any arithmetic sequence or explicit formula. So that's kind of the basis of what I'm going to show you next. We are going to derive this formula. So here we go. All right, first of all, when we have a finite series, let's just write it out. Okay, so it's going to be a bunch of terms being added up. The first term is obviously u sub 1. Well, how do you find the second term? And if it's an arithmetic, we just add d to it. So I'm going to write this as u1 plus d. Well, if I want the next term, then I'm just going to add another d to it. So this becomes u1 plus 2d. That makes a lot of sense. First term, the first term plus 1d, the first term plus 2d, and so forth. Now, this is where somebody who figured all this out was really slick. Remember, u sub n kind of stands for the last term. Okay, we have the sum of the first n terms. Well, the nth term then would be the last one. What is the term right before it? So instead of adding that constant difference, we could subtract it from the last term. So we're going to write this as un minus d. And that's the key move. That's the key move in this particular derivation. Well, then if we keep going with that, we get u sub n minus 2d. All right, so I would hope that you believe that, if we had some numbers, we could plug it in and that pattern would be fulfilled if it's an arithmetic sequence. All right. Well, what did I do here? I rewrote what we had up here, but I reversed the order of the terms, just like we did in 7 and 8. Very awkwardly, like without any direction. Why would somebody do this? Maybe you saw the pattern that some things canceled out and we ended up with a term that looked the same. Well, let's see what happens here. So here we have the last term going down to the first term. All right, so let's just see what happens. If we add those two, well, on the left, we're going to have two of these. The sum of the first n terms plus the sum of the first n terms equals 2 of the sum of the first two terms. Pretty cool. All right, when we add these two, we get u1 plus u sub n. Great. But check it out. When we add those two terms, look what happens with the d value. Cancels out. So we get u1 plus u sub n. That's pretty cool. And guess what? For all of these, if they're lined up correctly, you get u sub 1 plus u sub n. Now, if we put that in English, the first term plus the last term. The first term plus the last term. All right. Well, how many of those u1 plus u sub n's are we going to have? Well, there were n terms that we added up, so we're going to have n of those. So all of a sudden, we made this dot, 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 this thing that goes on forever, kind of manageable. So all of a sudden, wait a minute, what's our goal here? Our goal is to figure out what S sub n is, the sum of the first n terms. And we kind of have it manageable because all we have to do now is divide by 2. Ladies and gentlemen, to find the sum of the first n terms of any arithmetic sequence, you need to know the number of terms, the first term, and the last term. All right? That is so amazingly simple and beautiful. If for your notes there, I definitely want you to have what the n, the u sub 1, and u sub n is. N is the number of terms we're adding up. The first 50 terms, the first 100 terms, the first 3 terms. U sub 1 is always the first term, and u sub n is the nth term. Now, nobody understands what the nth term is. It's usually the last term that we're adding up to, but I want to say that generally because things can flux a little bit. So it's a great way to start. It's a great way to start. And don't forget S. S is the sum of the first n terms. All right, let's do our first example. Oh, sorry, this is a great time. Remember that little grid that we were filling out? Well, now we have something for this box, and I'm going to go ahead and give you the geometric series just for notes. That obviously is not here yet, but you can pause and write those down. All right. So our first example, find the sum of 4 plus 7 plus 10 plus 13 up to the first 50 terms. Okay, 50 terms. Really important for you to recognize what things you're given. First of all, is it arithmetic? Well, we're in the Arithmetic Series section. It probably is. But I want you to start asking yourself that question first because it's going to be arithmetic or geometric. It could be neither, and then you can't use a formula, but that's okay too. So it is arithmetic. All right. I like to kind of think about what do I know? I know that the first term is 4, the number of terms is 50, and darn it, I don't know the last term. So in my formula, I do know this, and this is kind of a question mark. So guess what? Just like anything, now that's our new problem. Now we have to find what is that last term. Well, we could add 3 a bunch more times until we get to the 50th term. But we're smarter than that because we have one other formula. That's it. And that is what we've been using. It's the explicit formula, the nth term formula. So we can use this to find u sub 50. All right. So what do? We just plug some stuff in. 4 is the first term. We want to know the 50th term. Plug 50 in for n, and we know the constant difference is 3. We just plug it in, we get 151. Now we know the last term. This is our u sub n. Just plug it into our formula. Number of terms over 2, first term plus last term. 3,875. Woo! That's it. So what are you going to have to get used to? Recognizing the information that's given, figuring out if we're missing something, how to go get it. It's probably going to utilize the one and only other formula that we derived in class. So it could be doable. Hey, on your notes, I gave you a second form of the summation equation. I'd like to show you how we got that real quick. This is the one we derived in class. So that's my favorite. In fact, I only use that, and then I use this when I need it. But some people like, oh, let's put those two together. So u sub n is right here, and u sub n is right here. We're going to substitute that in. And so when we substitute u sub n in, we get this little guy right there. And then we combine like terms. We got 2 u sub 1s, so we put those together. It looks a little clunky, a little bit, but what you'll notice after using it is it requires different information. So once you get good at this, you're like, hey, what information is given and maybe what formula is most effective. So we're going to do another example, but this time it's the same problem. We know what the answer is going to be, but maybe, just maybe, that other form would have been better. Always write down what you know. You know the first term, you know the constant difference is 3, you know the number of terms is 50. I like to write down what I don't know. I don't know what u sub n is. Okay, I know what n is, I know what u sub 1 is. So it's kind of nice to make sure you know, what you don't know. All right, so maybe we write down that formula. Maybe we have that stuff. Do we know the number of terms? We do. Do we know the first term? We do. Do we know the number of terms? We still do. And do know with the constant difference. So in this case, maybe that one's a little bit more effective. All right. The reason I showed you the other one first is I want you to know they both work. And sometimes one works better than the other, but it's always okay to use both methods. Plug and chug, 3875. All right. So let's do another example. We're going to find the sum of an arithmetic series. Starts with -6. And in this case, what do we know? We know it's arithmetic. Okay. It goes up by 7 every time. You know, as much as we can tell. We know the first term. We know the constant difference. We know the nth term. In this case, we don't know what term number that is. So that's the one that's kind of like, dang, don't know what that is. All right, so we have two formulas. And our question now is, which one are we going to use? Which one are we going to use? Well, in this one, we don't know what that n is. In this one, we don't know what that is, and we don't know what that is. So it's really kind of like both ways are not going to work like directly. So we probably are going to have to use the one other equation or formula for arithmetic sequences. The one other one might flush out what n is. All right. So we need to find n. We're going to use the one and only other formula for arithmetic sequences. And if you have that reference little box, it's right there. Just go get it. So what do we know? What do we not know? We do know the last term. It's weird. We don't know this n value, but we do know what u sub n is. So be proud and be confident about that. -6. We don't know what n is, and we do know what the constant difference is. At pre-calculus, you should know that this is a slam dunk. We can solve that for n. Oh boy. I got n equals 22. So now look what I write. I don't write s sub n anymore. I write s of 22. I am telling the world I'm going to add the first 22 terms of this sequence up. N over 2, first term, last term, 1485. All right. It's just kind of like giving you some new tools. I need to kind of walk away and let you just kind of plug and chug. Here's a little different one. I just want to kind of make sure that it can be presented in different ways. Arithmetic sequence, great. So right away I've got two formulas. I've got that third that I might use. They tell us the first term, so I write that down. The common difference, I write that down. In this case, for some reason, they know what the sum is. They know what the sum is. So it's important for you to understand what that means in notation-wise. That's s sub n. Do we know how many terms we added up? Whoa. Doesn't look, nope, doesn't, darn it, doesn't say anything. So we're going to start out with this formula. Why did we pick that one? We could pick either one. The other one, man, we don't know two things. We don't know the last term or n. So maybe This would probably be a little bit better since we know everything but 1. Interesting though, that one variable shows up twice. So as we work this thing out and multiply it out, quadratic. Don't be scared. Be empowered, okay? You're going down, you're doing what you're supposed to be doing. Just because a quadratic presents itself doesn't mean, oh, that's not this chapter. It's like, well, yeah, I can deal with that. Hey, we factor that one if you're lucky. You can use the quadratic formula. Either way, you're going to get negative 17 and 10. This is n stands for something. It is the number of terms. We do not have negative 17 terms. And interestingly enough, you might mess around with that a little bit just to see what that is. But in this case, we're going to take the positive. Good to go. All right. That's your homework. Under 16 minutes. These are all the same, but they're worded completely different. They're different scenarios. So take a deep breath, write down what you know, and it should go well for you. So you can turn off the video now. Fine. I just wanted to show you some things that people think about. Red Rocks. Gosh, I hope you've been to Red Rocks. I know my son hasn't. He's a senior. It's just demoralizing for me as a father that I haven't pushed him there. I haven't brought him there. I don't know why. But now seating needs to be spread out. So this would be a great question about if you knew some of the information, how would you figure out the number of tickets that you could sell without going and trying to count every other seat or whatever. It has to be 2 meters. So is the seating like that? Stuff like that, every other row. This is all going to set up series, arithmetic series, or maybe geometric, doesn't matter, that maybe you're adding 1 every row. So those are the sort of applications that you might see. I wanted to point out when we're adding a sequence of odd numbers, in the homework we should have created this formula. Great. 1, we get 1. If we add the first 2 odd numbers, we get 4, which happens to be 2 squared. If we add the first 3 odd numbers, we get 9, which happens to be 3 squared. So it suggests that if we add the first n terms, the sum is n squared. Okay, so that's hopefully what we got. But what I didn't show you is sometimes you can prove these things geometrically. So I just kind of wanted to show you this picture. This is a geometric interpretation of adding 1 plus 3 plus 5 plus 7 plus 9 plus 11 and so forth. This picture does not really kind of show you anything. But really cool, inventive, creative people change it a little bit and maybe it presents itself a little bit differently. So check out what I read about somebody else a little bit more creative than me. These are the same number of boxes, but I think it's okay if we just take one quick scenario here. Look at these right here. This is adding 1 plus 3 plus 5. Okay? But do you see if you bend it like that, it creates a square. Well, how do you find the area of a square? It's side by side. So this is 3 and this is 3. So when I add up the first 3 terms, I get a square that is 3 by 3, or 9. Kind of cool, kind of cool. One more little look. If I add the first 6 numbers, there's the 1, the 3, the 5, 7, the 9, and the 6, we get a 6 by 6. So that would suggest that all those squares would end up being a total of 36, and it does. So kind of cool. Hey, under 20, got to do that. The material is under 16, so I'm trying. No jokes today, I'm sorry. I'll do better tomorrow. See ya. Whoa. See ya.